So you can continue these from your notes from before, or you can start new ones. It's up to you. We're just going to continue to solve equations. Okay, so we're going to talk about a few other types of equations and the methods that we're going to use to solve them. And so I think we were on the 5th type of equation. So I'm just going to label that one number 5. And this is quadratic equations. So this is going to take on the form ax squared plus bx plus c equals 0. This is considered to be in standard form. Remember, we talked about standard form just being in descending order of the degrees. Okay. So a quadratic is where you have an x squared, so the squared term that's your highest degree. There's multiple ways to solve quadratic equations. We've talked about a few of those methods. The first is factoring. So you factor it, and then you have to use the zero product property in order to solve. Okay, this is your best option. It's the quickest option. However, it doesn't always work, right? So then there is option B, which is to undo or extract square roots. So we're going to practice some of these, but this is another quick method, okay, to use if you can solve for x that way. The next one I absolutely hate, and that is the quadratic formula. It's just so boring. But it is a method, and some students choose to use the quadratic formula for quite a few of these quadratic equations. I will tell you on the next quiz what I want you to use in terms of when I want you to use the quadratic formula and when we use our other method, which is completing the square. So I'll kind of guide you there. Because I don't want to see like 14 quadratic formulas, okay? But just to review, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm sure some of you have had to sing this at some point in your mathematical career here. We will not be singing in this hour, okay? Ever? Well, maybe not ever, but yes.
I've never learned this song. Can you teach us?
You can look it up on YouTube. There are multiple versions. Okay. If you just Google, quadratic formula song, you will see so many videos. We're going to do a quick example of this. I absolutely hate the quadratic formula, so every time this comes up, you're going to see me cringe a little, but it's okay. We'll get through it. So let's do a quick example. Let's say we have 3x squared minus 2x equals 2. Okay, now first of all, we have a small problem here, right? Because it's not in standard form. So anytime you go to solve a quadratic equation, you really want to get it in standard form. So the only thing we have to do is move the 2 over. So I'm going to have 3x squared minus 2x minus 2 equals 0. When you're thinking about the quadratic formula, you want to try to find, a, b, and c. So a is 3, b is negative 2, and c is negative 2. Try not to lose those negatives, all right? And then we're just going to plug it in. So x equals negative b. So that's going to give us a positive 2 there when we plug it in. Plus or minus the square root of b squared. So negative 2 squared minus 4 times a, which is 3, times c, which is negative 2. Now, a common mistake students make is they don't divide the entire expression in the numerator by 2 times a. So just make sure you draw that nice big fraction bar. Okay, and keep in mind that the entire piece is under, or is over 2a. Okay, so now we simplify. So we get 2 plus or minus the square root of 4. Let's see, negative 12 times negative 2 is going to be a plus 24 all over 6. This is where our simplifying radicals is going to come in handy, right? So this was 1.2, the first lesson we did. Here we get a 28. That's like 4 times 7. So we're really getting 2 root 7 there, right? This is the square root of 28, 4 times 7. Keep in mind. Now, The only way you can simplify at the very end is if all three of these terms have a common factor. So between 2, 2 root 7, and 6, everyone agree there's a common factor of 2? Okay, so these can simplify by dividing by 2. We get 1 plus or minus root 7 over 3. Everyone comfortable with the quadratic formula, how to identify A, B, and C, how to plug it in and simplify? Okay, good. I will hopefully not have to do that for a while. All right. The next type of quadratic equation is, well, the method to solve is completing the square, which is my favorite. We are going to complete the square so much in this class. You have learned this before. You learned this last year. This is, a method that students don't tend to like at first because it's a little bit more difficult, but then towards the end, once you're comfortable with it, it'll be very quick, okay? So we're just going to work on it. Now, I am going to make a lot of steps over here on the side in order to follow along. So if you want to do that, feel free. So here's our first example to complete the square. We have x squared minus 8x plus 5 equals 0. Okay, so we're going to make some steps over here. There are really two methods that you can use to complete the square. I'm going to show you one method because in a couple weeks we're going to revisit this and we're going to use it. So I think if I show you both, it's more confusing. But you may have learned this a little differently last year, okay? All right, so the first thing we're going to do is we're going to, this is a lot of technical terms here, okay? Scoot over the C term. Okay, super technical. So we're going to just scoot that right on over. So we're going to make a little bit of space. So I'm going to have x squared minus 8x, and then I'm just going to scoot that plus 5 over to make some room. Okay? I'm going to label this step 1 so you can follow. Step 2. We are going to make sure you have a coefficient of 1 for our squared term. If not, factor out a from only the first two terms. Okay, so right now, if we look at our x squared term, we have a coefficient of 1, so we don't have to worry about this step, okay? So this is really step 2 as well, but it's done for us. There's nothing to do here, so we're ready to move on to step 3. Step 3, take half of b and square it. Then you're going to add and subtract that term. Okay, so let's label this step 3. You could put a 2 here as well if you wanted to, or maybe just draw 1 and then label it step 2 so you know that you didn't have anything to do there. So step 3 says, now that you have a coefficient of 1 for A, you need to take half of B. So when I take half of negative 8, I get negative 4, right? I have to square it, and I have to add and subtract it. You have to keep the equation balanced. So if I add 2, I have to also subtract 2 in order to really add nothing, right? It's keeping your equation balanced. I'm just changing the look of the equation in order to create this perfect square. So I get x squared minus 8x. Now I'm going to add a negative 4 squared. But remember, I still have this plus 5. I'm also going to subtract a negative 4 squared. Step 4, you're going to factor and simplify. Okay, so now for step 4, I have to think about what I have here. So negative 4 squared is really like 16, right? So I'm adding and I'm subtracting a 16 here. So that's how I keep that equation the same. It's just a different look. What's happening here, if you put parentheses around this, is you've created a perfect square trinomial. So thinking about how a perfect square trinomial factors, it either factors to a plus b squared or a minus b squared. Because I have a positive 16 and a negative 8, I'm going to have a minus. So this is going to factor to x minus 4 squared. And then here I'll just simplify. 5 minus 16 is going to give me a minus 11. Okay, so the whole reason we complete the square is to create a perfect square trinomial in order to factor it. Once you've done that, you're moving on to step 5, which is to solve for x. Okay, so now in order to solve for x, I'm going to add over the 11. How do I solve now? What do I have to do? Yes, Zach, right? Okay, so take the square root of both sides. Now, when you're taking the square root of both sides and you're solving for x, what do you get in front of that square root? A plus or minus. Very good. So plus or minus the square root of 11. You want to think to yourself, does the square root of 11 simplify? It doesn't, right? It's prime. So now all we have to do is add over the 4. So our solutions are 4 plus and minus the square root of 11. Now, you could solve this problem using the quadratic formula. You would get the same result. Okay? You are going to be forced to complete the square, though. So on your quiz, on your next quiz, it'll say solve using the quadratic formula, and then the next problem will say solve by completing the square. Okay? So you have to use the method that's asked of you. Do you remember this from last year? Probably, maybe the only difference is that you moved this c term over to the other side and then you worked on both sides of the equation. Okay, you can still use that method if you would like, but this will come in handy later on. Okay, we're going to definitely try another one of these because they're difficult. Okay, so let's look at this. 4x squared plus 8x plus 1 equals 0. Okay, so the first thing I'm going to do is step 1. I'm going to scoot over the c term. So I'm going to have 4x squared plus 8x, make some space, put my plus 1, and then equals 0. Okay, now step 2 says make sure that you have a coefficient of 1. So do you see here I do not have a coefficient of 1. I have to take care of this before I can start to complete the square. This is different than the previous example because in the previous example we did have 1, so we didn't have to do anything else. So here we have to factor out that 4 because you have to have a coefficient of 1. So I'm going to take a 4 out of the first 2 terms only. So this is going to leave me with x squared plus 2x. I'm still leaving that space, and then I have my plus 1 here. Okay, so you have to have a coefficient of 1 for x squared. So you take it out of the first 2 terms only. Now I can move on to step 3. Take half of b. So half of 2 is a positive 1. So I'm going to add a 1 squared here. Now I have to subtract it, but I want you to think about this. Am I really just adding 1? Jack? That's exactly right. Okay, and this is where students forget. This 4 is getting distributed to every term within there, right? So that means I'm not really adding 1 inside. I'm really adding 4, because 4 times 1 is what I'm truly adding. So if I'm adding 4 on the inside, the only way to keep it balanced is to do the opposite on the outside. So if I'm adding 4 here, I have to subtract 4 here. Maybe highlight that or something, because this is, you know, the most common mistake made when completing the square, okay, is you forget to factor in, you know, you have to distribute to every one of those terms. Okay, so now I'm ready to factor and simplify. Now don't lose this 4. It's got to drop down with your equation. So we have 4. Now, some teachers will square this term and just write a +1 there. Okay, then you have to just factor. What I always do is I just write it like this, and then I know exactly what it's going to factor to. If this is a +1, then this factors to x plus 1. If this was a -2 squared, then this would factor to x minus 2. If this was a plus a -10 squared, then this would factor to x minus 10. So I don't really have to think about what it factors to if I write it like this. Like if you go back up, I wrote a -4. Well, look what it factored to, x minus 4. Okay, so for me, it's just like a little shortcut I use. You don't have to do that. You could just square this and then think about the perfect square trinomial that's created. Okay, so now this is squared, and I have a -3 equals 0. So now I've factored it, I've simplified it. Now it's time to finally solve. So I've set it up so that now I can have a quadratic equation that is solved. So I'm going to add over the 3, and I'm going to divide by 4 at the same time. So I get x plus 1 squared equals 3 over 4. At that point, I have to take the square root. But I want you to remember how to do this. So let's just make ourselves a note here. Remember, if you take the square root of 3 over 4, it really means the square root of 3 over the square root of 4, right? You'd have to take the square root of both of them, the numerator and the denominator. So this is going to give us the square root of 3 over 2. Now, if when we simplified we still had a square root in the denominator, you'd have to rationalize it then, okay? So here, when we take the square root of both sides, we end up with x plus 1 equals plus or minus the square root of 3 over 2. And don't forget your plus or minus. Last step is we're going to subtract over the 1. So x equals -1 plus or minus the square root of 3 over 2. Keep in mind that when you're solving for any of these types of equations, you're really solving for those x-intercepts, right? That's what you're finding. That's what x represents, is the x-intercepts of the graph. So that's why there are 2 here, right? Think about the plus or the minus. You get 2 because every quadratic is a parabola, right? So you're going to hit that x-axis possibly at 2 points. So that's why we're getting the plus and the minus. How are you doing on completing the square? How many people remember this? Okay, how many people this is vaguely familiar with, but maybe you did it different last year? Okay, all right, we're going to keep working through this because, like I said, this is a skill that you have to master for the year. Okay, we're going to move on to the next type of equation, which is radical equations. Okay, for radical equations, you must check for extraneous solutions. Some of them it's just a good idea for, like it would be helpful to check to make sure you got the right answer. Some of them it's mandatory because a lot of times we'll get an extraneous, they're more prone to an extraneous solution. Okay, so there's 2 types we're going to look at. The first is if you only have one radical in the equation. When that happens, you're going to follow these steps. 1, isolate the radical. 2, square both sides. on 3, solve and check. Okay, let's do one of these. So for example, let's say we had the square root of 3x minus 2 minus x equals negative 2. Okay, so here we have a single radical. The first thing we want to do is we want to isolate it. So in order to isolate it, we're getting it by itself, we should add over the x. So now we have the square root of 3x minus 2 equals x minus 2. Once you have the radical isolated, we're going to square both sides. Okay, now this is another part where students will do something super illegal, okay? You want to square that first and last term. It's just like something some of you really want to do. It would be so easy, but remember, x minus 2 squared means x minus 2 times x minus 2. You can't lose those middle terms. You have to distribute to everything, okay? So we're going to get, when you square square root, it creates a perfect square, right? So the radical goes away, and we're left with 3x minus 2. Here, when we square that binomial, we're going to get x squared minus 4x plus 4. If you can't do that in your head, then you should write this step out so you can see the distribution happening to all of the terms. Okay, at that point, we've gotten rid of the radical. Now we have to get everything to one side in order to factor. Okay, so we're going to pull everything to one side. We're going to get x squared minus 7x plus 6. The hope when you get there is that it will factor. Sometimes you get here and it won't factor, and then you either have to use quadratic formula or completing the square. Okay, so these problems can get kind of lengthy. In our case, though, luckily this factors to x minus 2 times, let's see, x minus 6 times x minus 1. Right, we need a positive 6 and negative 7. We can use a zero product property now, so we take each one of those pieces, we set it equal to 0. You don't have to show me that step. You should be able to do that in your head. So x is going to be 6 and 1. But once you've gotten here, you have to check your solutions. Okay, so we have to go back. So when you check, you have to plug it back into the original. So you can do this in your head, you can do this in the calculator, you can write it out. I don't care. I will know if you check because you'll have the right answer. Okay, so this is, let's see, 18 minus 2, that gives us the square root of 16 minus 6, which is 4 minus 6, which is negative 2. This is a good solution. So 6 works. Now we have to check 1. We have 3 times 1 minus 2 minus 1 equals negative 2. 3 minus 2 is 1. The square root of 1 is 1. 1 minus 1 is not negative 2. It's 0. So this is a bad solution. It's extraneous. All you have to do is draw a line through it. You can write ext. And then I would like you to separately list the good solution of x equals 6. Questions on solving with one radical? Okay, now we're going to probably do your least favorite problem. You'll need some space for this. So if you're like at the very bottom of your page, you might want to turn the paper. This is not a good page. Okay, now with radical equations, you could have two radicals. So let's write out some steps for this. So it starts out similar. You have to isolate the radical, but now what we're going to do is we're just going to isolate one radical. Then we're going to square both sides. Step 3. Once you get there, you're still going to have a radical left over. You have to isolate it again. So isolate the remaining radical. Step 4, you have to again square both sides. Once you do that, finally you will have both of your radicals gone, and then you can just solve and check. So this problem is like a 2-for-1 special. You really have 2 problems in one to solve. It's not the most fun, but you know, it is what it is. So let's try one of these. Let's say we have the square root of 3x plus 4 minus the square root of x plus 5 equals 1. Okay, now technically you can square both sides right now. You won't get rid of the radical. It'll just make a much more complicated problem, okay? So the best way, the easiest way to do this is to isolate one of those radicals. So I'm going to add over the square root of x plus 5. So step 1, isolate one radical. So I've done that. I've isolated this square root of 3x plus 4. Now I have to square both sides. Okay, I'm going to actually take the time to write this out because this one's a little harder to see. So when you square the square root of 3x plus 4, you just get 3x plus 4. That part's easy. Now this means that we have to multiply the square root of x plus 5 plus 1 times the square root of x plus 5 plus 1. So I still have this 3x plus 4. Okay, so let's take a look at this. I have the square root of x plus 5 times the square root of x plus 5. That just gives me x plus 5. Then I have to distribute to the second term. So now I have plus 1 times the square root of x plus 5. Just gives me the square root of x plus 5. Now I'm ready to move on to the 1 and distribute it. So now I distribute it to the first and get another plus the square root of x plus 5 and plus 1. Questions on the distribution? Okay, once I'm there, I'm ready to combine like terms. So I'm going to get 3x plus 4 equals x plus 6 plus, now this is like saying the same exact term, right? They both have a coefficient of 1 in front of them. So when I add those together, I get 2 times the square root of x plus 5. Everyone understand that? Okay, so now I'm going to move over. See, now I'm on to step 3. So notice I don't have this radical gone. I have to deal with that, and I'm really back where I started, right? In the last example where I only have one radical, I have to isolate it, and then I have to square both sides. So I'm going to move over this x, and I'm going to move over this 6. I get 2x minus 2 equals 2 root x plus 5. Okay, now let's talk about once you get here. In this case, if I divide by 2, both of my terms have a 2, so I won't be left with a fraction, right? They divide evenly. So you could divide by 2 right now, because it's an easy option. But what if this were a 3? If it were a 3, we couldn't get it to cancel, right? So we could just square both sides right then, which you can do right now. The only thing you have to remember is that when you do square both sides, you have to also square the coefficient. Okay, so if this were a 3, I would choose to square both sides right now. Do you understand why? It's going to get real messy over here with 2/3 and 2/3. I don't want to deal with fractions, okay? But since it's a 2, we could divide. So I'm going to divide by 2 everywhere. Remember, both of those terms are divided by 2, so I get an x minus 1 equals the square root of x plus 5. It seems like I should be done with this problem, but I'm really just getting started, right? Because now I got to square this again. So it's time to square both sides again. I have to FOIL this or distribute it. I get x squared minus 2x plus 1 equals x plus 5. I then have to bring everything to one side. So I get x squared minus 3x minus 4. At this point, I'm so ready to quit because I have so many steps. I'm just really hoping it factors. Sometimes you get to this and then you get to complete the square. Okay, so these are not really a lot of fun. Now, luckily, this factors, right? X minus 4 times x plus 1. Okay, use the zero product property. We get 4 and negative 1. It would be so nice just to circle these, but I can't because I have to check. Okay, so now I have to check these. Remember, when you check, you have to go all the way back to the beginning because in this middle, you could have made a mistake, right? So we want to go all the way back to the original problem. We want to check our solutions. I don't really care if you just do it in your head, okay? It's your choice, but we have the square root of 3 times 4 plus 4 minus the square root of 4 plus 5 equals 1, maybe. This gives me 12 plus 4 is 16. Square root of 16 is 4. Square root of 9 is 3. This is a good solution. Okay, so 1 equals 1. Now we'll check the second. So I have 3 times negative 1 plus 4 minus negative 1 plus 5 equals 1. Let's see, this gives me the square root of 1, which is 1. This gives me the square root of 4, which is 2. Negative 1 does not equal 1, so this is not a good solution. So my only solution here is x equals 4. Questions?